We have the next speaker is going to talk about testing, and he lives also in London, like myself. We actually met during a meetup not long ago, so give him a round of applause, please.
Thanks, guys. So I hope everyone had a nice lunch. I had a lovely burger, and I'm ready to start talking about unit testing Vue components. So we're going to talk about what unit testing is, why we should unit test our components, and how we should unit test Vue components. My name's Edd Yerburgh. I'm the main author of Vue Test Utils, and I do a lot of work to improve the unit testing experience of Vue. You can find me on Twitter @Edd Yerburgh. So hands up if you've written a unit test before. OK, almost everybody. And keep your hand up if you've written a unit test for a Vue single file component before. OK, a lot less of you. So for those of you who've never seen a unit test before, imagine that we have a sum function, and it just adds two numbers together. We want to test that this function works. So one way of testing it, if it was in an application, say it was a calculator application, would be to open up the application in the browser, click some buttons, and check that the sum function is working. But we're not actually checking the function itself here. So if something went wrong, we wouldn't be sure whether it's a problem with the function itself or with some other code in our application. So another way to check that the sum function is working is by writing a unit test, which is basically a piece of code that calls another piece of code and then reports back to us on whether that code returned the expected input. So here's a simple unit test for our sum function. We import the sum function, and then we define a test. So we're using Jest as a test runner, and Jest is going to pick up this test and run it and report back to us on whether it passed or failed. So we give it a spec name to identify it in the output, and then we have the actual test function itself. So we have an expect function, which takes a value, so the sum of 1 and 3, and then it returns matcher functions. So here we're using a 2b matcher, and that matcher function takes a value and compares it to the value that expect was called with. And if the values match, then it doesn't do anything, and the test will pass. If the values don't match, then it throws an error, and the test will fail. So when we run Jest in the command line, it's going to find this file, run the test, and if the sum of 1 and 3 does return 4, we'll get some output like this. So it tells us that the unit test is passing. If the sum of 1 and 3 doesn't return 4, then we'll get an output like this. It tells us that the test failed, and it gives us a good idea of why it failed. So that's what a unit test is. I think the next question to answer is, why should you write unit tests? Why write extra test code for your application when you could just go ahead and write the application code itself? Well, there's a load of benefits that I've seen from writing unit tests in projects over the last few years. One of the biggest benefits is that you can check that components work correctly. So just being able to enter a command and see that your changes to the code haven't broken any existing functionality makes writing an application and maintaining an application a hell of a lot easier. So if I made a pull request on GitHub, for example, we could have a server pick up the changed pull request, run the unit tests against it, and report back that the pull request hadn't broken any existing unit tests. Another big benefit of unit tests is that it provides documentation. So if you're working on a component that you've never seen before, and it has a test file, you can open that test file, and as long as the tests are passing, you can see exactly how that component behaves. So instead of working on a really long component with no idea of what its intentions are, you have this test file, you know exactly what the intentions of the component is. If something does go wrong and you have unit tests, debugging's a lot easier. So I'm in the habit of writing my test code before I write the source code, and then running the tests after I've written the code to make the test that I wrote pass. So I know very quickly if the code I just wrote broke some existing functionality. And if the tests are written well, then I normally know how I can fix it. Ultimately, unit tests just lead to less bugs, and I found that they make development such a nicer experience. So we've looked at what unit tests are and why we should write unit tests, but the biggest question is how to write unit tests and how to write effective tests for components. Because although having no test for a component can make it really difficult to develop and really easy to introduce bugs, at the other end of the spectrum, if you have tests for every single line of output of a component, every single element that the component's rendering, you can get into a problem where you're hesitant to refactor and change your components because you're tied to the test that you've already written. So to look at how to write effective tests for our components, we're going to write a component, a modal component, and write the unit test for it, and then some snapshot tests to safeguard against any future changes to the code. So first, we look at this view single file component. And the first thing you notice about it is that it's not valid JavaScript. So if we try to run this in the browser or in Node, we get an error. So we need to compile it. And once we've compiled the single file component, the template block will be compiled into a render function and a static render functions if they exist, and merged into the object that we're exporting in the script block. So there's a compilation process when we're writing unit tests for Vue. We're going to write our Vue single file component and then import it into a JavaScript test file and then run it through a compiler before we can actually run our unit tests in the test runner. To show you how much of an impact the compilation can have, I got curious a few months ago and ran a performance comparison of different test runners with Vue unit tests. And the results were staggering. So while some of the test runners only took 38 seconds to run 5,000 unit tests with Vue single file components, which is really reasonable, Ava in particular took over an hour to run 5,000 unit tests. And it's not because Ava's a bad test runner, it's just that I wasn't effectively caching the compiled components in my testing process, which ended up leading to this really long testing time. So you need to consider your compilation process as part of your unit tests. And the best way to do that is to follow an established pattern. So there's two main compilers that we use when we write Vue unit tests. First, you can use Webpack, which you're probably using to bundle your production code anyway. And also, you can use Jest as a compiler. So Jest has its own transformer system. And there's a Vue.js transformer that's maintained by the Vue organization that transforms our single file components. The trade-off here is that you're using a different compiler to the one that you're using to generate your production code. But because they're both maintained by the Vue organization, and under the hood they're going to use the same library to compile, I think it's a fair trade-off. So in our example, we're going to use Jest as the test runner, mainly because it's a zero configuration approach to testing, which means you have to write a lot less config to get the testing setup going. So we're going to imagine that we're working in an application built with Vue CLI, and we've got Babel set up, and we've got all of the scaffolding ready. We just don't have any tests or any testing framework set up. So the first thing to do is install Jest and Vue.js, the transformer for Jest that will compile our Vue components, and Babel.js, which will compile our JavaScript. And then inside our package.json, we need to add a Jest field. So by default, Jest is going to look for config options inside package.json file. We just need to add this transform object that takes some regex, and it will match. Jest is going to match file path strings against this regex and use the transformer that we've told it to. So any file that ends in a .js extension is going to use Babel.js is going to be transpiled with Babel.js, and any file that ends with a .vue extension is going to be compiled by Vue.js. And once we've got that set up, we've pretty much got everything to start compiling our Vue files and running our unit tests. we just need to write a unit script, and all that's going to do is run Jest. And then we can run our tests by running npm run unit in the command line. And that's going to run Jest, which will look for all the files with the .spec.js extension and run them, find the tests, and report back to us on whether the test passed or failed. So we've got our testing framework set up, and when we import the Vue single file component now, it's going to be compiled by Jest before we run it in the tests. So if we look back at the compiled single file component, we have this object with a render function. How do we take this object and turn it into something that we can use to test? One way is by using vue test utils. So we're going to install that and save it as a dev dependency. Vue test utils exposes this mount method, which basically takes a component and creates a component instance. So it's a fully running component instance, and returns a wrapper object. So here we're importing mount, and we're going to import our single file component. And then we create a wrapper object by calling mount with the component. So that's going to return an object that contains a reference to the component instance of wrapper.vm and a reference to the root DOM node, wrapper.element. So now we've got all the ingredients to start writing some tests. And we'll look at some of the helper methods that the wrapper object has later. But before we do that, we actually need to decide what tests we're going to write. And I think this is probably the hardest part of writing tests, is trying to decide what you should write, what tests you should write, and what tests you shouldn't write. So one way that I've found to decide what tests to write is this idea of a component contract. So a component contract is like the interface that your component has with the outside world. It's what your component does. I like to think of it as if I was writing a page of documentation for my component, the details that I put onto that documentation are the things that I'm going to test. That's the core component contract, the core functionality. So a component contract's like an agreement between your component and the rest of the world that says, if you provide me with this input, then I'm going to generate this output. And that dictates what we're going to test. And one of the reasons that component contracts are so powerful for writing our tests is it really makes us focus on the input and the output, which means we avoid testing implementation details and make it easy to refactor how our components work under the hood, which is sort of one of the benefits of having a good unit test suite. So the input for Vue components, it could be a user action. This is a really common form of input, is a user clicking on a button, for example. That's input for your component that it's going to react to. Another form of input are the props that you pass down to a component. So providing a component with the correct props is a form of input. And another form of input that you might not think of is actually providing a store with the correct data. So if you have a component that uses a store and expects some data in that store, you're going to have to provide that in the test as a form of input to be able to check whether the component does what you expect it to do. And the output of a component, it's the rendered output. So that's probably the most common output. That's the DOM nodes that are rendered by the component, a combination of the DOM nodes and the Vue instances. Another form of output is Vue events. So if a component dispatches an event that's picked up by the rest of the application, that's a form of output. Another form of output could be function calls. So if a component commits a mutation, a Vuex mutation, that's a form of output that we can test. So we're going to write a test for a modal component. And before we decide what test we're going to write, before we use the component contract, we should look at how it's going to be used. And that's going to give us an idea of what tests we need to write. So when we have our modal component, it's going to take a visible prop. And depending on whether that's true or false, it's either going to render or not render. And then we can pass it an on-close click handler. So this click handler is going to be called by the component when the close button is clicked. It's also going to take some slot content that it will render. So I think the first test we can write is that it doesn't render when not past a visible prop. So the first thing to do is create a wrapper by calling mount with a component. And then we can use, we need to check that it doesn't render anything, that the render tree is empty. To do that, we can use a vue.test.utils isEmpty method that's on the wrapper. So this is going to return a Boolean. It's either going to return true if the wrapper is empty, if the DOM tree is empty, or it's going to return false if it isn't. So we just write this expect that the wrapper is empty to be true. So the next test we'll write is to check that it does render when passed a visible prop as true. So to do this, we need to know how to pass props into a component when we're using vue.test.utils. And mount takes a mounting options object as the second argument. So in this object, we can pass in props data. So it's worth noting that mounting options takes a combination of vue.test.utils options that are used when you mount the component, but it passes every other piece of data through to the component when it's created. So this props data object is actually a Vue core option. So we're going to mount the modal, pass in a props data object with visible set to true. And that's going to create our spinning component, create our wrapper with visible set to true. So then we can just write the opposite of the assertion that we wrote in the last test. We just expect that wrapper is empty is going to return false. So the final unit test we're going to write is to check that the modal component calls the onClose click handler when the button is clicked. To do that, we're going to use a mock function. A mock function is basically a function that can record data about how it was called. So we can create a mock function by calling the Jest function method, and then pass that into the component inside the mounting options. So onClose is going to be this mock function that we created. And then we need to trigger a click. We need to provide the input of a click to check that onClose has been called when that click happens. And we do that by calling wrapper.find. So wrapper.find takes a selector and returns a wrapper of the first node that matches the selector. So wrapper.find is going to traverse the render tree, find the button node, return a wrapper that contains that node, and then we can call the trigger method, which is going to dispatch a DOM click event on that node. So to finish off the test, we need to add our assertion. We just want to expect that onClose has been called, to have been called. So that's a Jest matcher that checks that a Jest mock function has been called. Another test that you might think we would write is that it renders the slot content. But I'm hesitant to write a unit test for something that's so simple, because I think we can capture it better with another kind of test. We'll look at that in a second. So if we wrote our component to pass all the tests that we've written, we'd end up with something like this, which isn't really very useful. Like, it meets all the core functionality of the component, but if we render this in an application, it would look terrible. So we need to style it. We need to add some classes. We need to add maybe some ARIA labels. And we can do all that without writing a unit test and end up with something like this. So you might be wondering, why aren't we testing this? Well, I think that if we wrote unit tests for all of these classes, we're really tied to the DOM hierarchy that we've created. So instead of writing a unit test, we can write add all these styles, and then we're going to have to check manually in the browser that these styles have been applied correctly. So there's this manual element of testing here. And instead of writing a unit test for all this, we can capture the changes that we made with a snapshot test. So a snapshot test is a way of safeguarding against any unintended changes to a component's output. we'll write one now and then look at the logic that Jest follows when you run a snapshot test. So the first thing to do is create our wrapper. And we're just going to mount our modal component, pass in props data with visible set to true, and then we're going to write the actual snapshot test. So to do that, we call expect with wrapper.html. So here, wrapper.html is you can think of it as the output of our snapshot test. And it's just going to be a string of the HTML of our mounted component. And then we can use this toMatch snapshot matcher. And this is going to trigger the snapshot test. So when Jest runs this test, it's going to see the toMatch snapshot matcher. And it's going to run through this logic. Firstly, it checks if a previous snapshot exists. If it does, it will compare the new output, so the value that we called expect with, to the previous snapshot. If a snapshot doesn't exist, then Jest will create a snapshot file, and the test will pass. So when we compare to a previous snapshot, basically Jest just checks, does the output match the previous snapshot? If the output does match the previous snapshot, the test will pass. If it doesn't, the test will fail. So the first time we run this, there isn't going to be a snap file. So Jest is going to generate one in a snapshots directory, and Jest manages all of this automatically. If we look inside the snap file, it's basically this exports syntax with a string, which is the value that we called expect with. So here it's just one really long string, which is problematic because part of the value of a snapshot is that you can diff between the previous snapshot of your component and the latest snapshot. So we want to add some formatting. To do that, we need to install Jest Serializer Vue, which is a library that formats snapshot tests, view output for snapshot tests. So we just need to add a snapshot serializers array in our package.json and pass in Jest Serializer Vue. And if we run the tests again, we'll get some output like this. So the test is failing. And the reason that it's failing is because the new value that we just called the snapshot test with has been formatted. So it doesn't match the previous snapshot, which you can see is just a long string. So obviously, we want this change to happen. We want our new formatted output to be the saved snap file that we compare against in the future. So we need to overwrite the snapshot. We can do that really easily by running our unit script and then passing in this U flag, which basically is an alias for update snapshots. So once we run this, Jest will update the snapshot to use the new value that expect just was called with, and the tests pass. OK, great. One final thing that we need to do, though, is test the slot content, because you might have noticed that we actually are rendering the slot content now, but we're not testing for it. So we need to pass some slot content in when we mount our component. We do that with the vue.test-utils slots object. So slots takes a default prop, so this is just an unnamed slot, and it's going to mount our component with this as the default slot value. So we're going to mount it with a p tag, with something that says some content. And then we'll give it the props data with visible set to true. And we'll just write a new snapshot test using the HTML. So once we run that, we're going to get a diff like this. And this is the sort of usefulness of snapshot tests, is when you've got a fully formatted component and you get a diff like this. And obviously, we want to overwrite this with the new snapshot that's actually rendering our slot component. So that's actually all of the tests that we're going to write. If we look back at what we did, we wrote some unit tests for the core component contract, which didn't really lead to a fully functioning component. And then we had to style it, which involved some manual testing. We'd have to open up the component in the browser and check that all the styles have been applied correctly. And then we can use snapshot tests to safeguard against any unintended changes to the output of a component after it's been styled. And the benefit of snapshot tests is they sort of act as a prompt to the developer. So if you do accidentally change the output, your tests are going to fail, and you'll be prompted to look at the component manually and check that it's still rendering correctly. So if you want to go further from here, the best place to get started is with the Vue test utils docs. We've got a load of guides on using different test runners and testing Vuex and Vue router. But if you want to get really advanced, I highly recommend my book, Testing Vue.js Applications, which actually is 40% off today only with the code CTW Vue.js Amsterdam 18. So if you guys want to take a picture of that and use the code later, it would be much appreciated. And that's everything, guys. Thanks for listening.